So I got up very early this morning to head out to take a look at one of Utah's more famous rock layers, the red beds of the Chinle Formation. So I love this section because every time I come out here, I find new petroglyphs, and we're standing actually right next to the Nugget Sandstone, which is Jurassic. Some people have recently suggested it's late Triassic, and it's a Aeolian formation, and it caps this ridge, and underneath this is the Chinle Formation, which we're going to see. But this sandstone, this wonderful Aeolian sandstone out here, is just filled with wonderful Fremont petroglyphs that have been chiseled. So these are ones that they actually took a stone and chiseled into the rocks. And the rocks out here are just covered with petroglyphs. And part of that is because this area, we have a nice river coming through here. It's a great place for camping, fresh water. And so this place was inhabited 1,000 years ago. And it's just a really, very special place to come to and see some of these wonderful petroglyphs that are here. And every time I come here, I see new ones on the walls. And just look at this panel behind me. There's just hundreds of petrographs that you can come and see here in this valley. And it's a wonderful ridge, and it's a really kind of amazing, special place. They go way up there, up high. So I don't know if you can see it, but if you look up there, up right on that ledge there, zoom in and take a look at that little lizard someone carved way up there on that rock ledge. And actually, if we scan over, we can see that there's actually lots of lizards that have been carved in these rocks up here. So I wanted to come out here early in the morning to get some great light on some of these petroglyphs so they would show up really well in this video. But I also wanted to look at this particular section here because it represents a boundary between two formations. Now in geology, the term formation has a very specific definition, and that is that it's a layer of rocks that has some sort of lithology that's unique and that can be mapped, and the fact that it can be delimited from other layers of rocks is what makes it a formation. Now I've come out here because we have the contact between the Nugget or Navajo sandstone above and the Chinle down below. And that contact is right here. And we can see that we have this massive sandstone. This is the Nugget or Navajo that's above me. That's what the petroglyphs are all carved into. Now below this, right at the contact, we have a different layer of rock. And this layer of rock is a mudstone rather than a sandstone. It's kind of a reddish, brownish mudstone underneath here. And we have this very sharp contact here. There's not a gradation between these two units. And so this represents probably a missing piece of time between these two units. This is what we refer to as a unconformity. And what's really fascinating about this unconformity here is that in another section not too far from here, the Utah Geological Survey has proposed a new formation called the Bell Springs Formation for a unit of rock. So I wanted to come out here and take a look at this contact between the Chinle and the overlying nugget sandstone. Now, there's really something really cool in this outcrop as well. If we look over here, we can see that this sandstone comes all the way down here to almost into this mudstone. And this is actually a fault that you can see right behind me. So this goes all the way up through the nugget sandstone and it comes down through here. So this is a normal fault, and what's happening here is that these rocks over here have fallen down. It's sort of slid down. Normal faults are extensional faults, so the rock layers are being pulled apart, and this part kind of dropped down and this part stayed up. And so we can see that in this outcrop right here, this wonderful fault. So we're going to walk around here and take a look a little bit at this contact to see if we see any evidence of a different formation, the Bell Springs Formation. So this is that layer I'm looking at. So you can see that there's some sandstones in here. They're sort of interbedded with this red mudstone. And what I'm looking at is the nature of this sandstone, whether this represents something that might be Aeolian, like the overlying nugget formation. And what's really kind of fascinating is you do see some Aeolian type cross-bedding here. So this seems to indicate that there might have been some interplay between the overlying nugget formation and these mudstones. And so I think there might be a case that this might actually be a new formation, the Bell Springs Formation here, within here. So one of the things we can look at is this layer of sandstone that's below that reddish mudstone. If we follow it over, we see that that mudstone sort of decreases in thickness, and that sandstone sort of becomes part of this upper sandstone of the nugget. And that's something we refer to as interbedding, which indicates that maybe these two units are sort of the same. And so this intermediate formation that we're looking at in between us that has these mudstones within it, interbedded within it, might represent a new formation that's sort of intermediate, the Bell Springs Formation. If we look down here, we see this clay that comes down, this grayish clay. These probably represent burrows or some sort of bioturbation. Might even be some roots that grew here. And this may have been an ancient soil horizon. So we're dealing with terrestrial rock layers. And that's one indication. There's some sort of organism. It might have been a plant or an animal that was digging down into here, into this mud. And you see these interesting molded patterns. And this is very typical what you see in a lot of ancient soil horizons. So this probably represents a wetter period, and then we're drying up into these Aeolian sand dunes. But really nice exposure of this unit here. So we're looking at the Chinle Formation, and right down in this valley we have a sandstone. We're going to go down and take a look at this interesting sandstone. This is what's referred to as the Gardea Member, the Gardea Member of the Chinle Formation. And it's a really interesting unit. It's more of a sandstone conglomerate unit that's the basal member of the Chinle. Now in southern Utah, there's another very similar type of unit called the Shirrup member. And that is very similar, but it's not believed to have been deposited at a different time period. And that's because geologists had followed this layer down to southern Utah and found that it pinches out. And it's believed that the Chinle was sort of deposited in two separate basins, a northern basin and a southern basin. And it was divided by the Uncompadre uplift that existed during the Permian. Now I'm situated right now in a syncline. What a syncline is basically where the beds have folded down. and it's the opposite of what is called an anticline. An anticline is where the beds are folded up. Now the syncline means that these layers have folded down, kind of like a fold in a paper coming down. And so what ends up happening is that on the flanks of this valley that's right in here, we have the older Permian Weber Formation, or the Weber Formation. So Blue Mountain, which is right behind me, is composed of the Weber sandstone as it comes up and over as part of the anticline in that hill behind us. And then right in front of me is a big, massive outcropping of the Weber sandstone, another Permian aged rock. And so this valley in here is where we have the younger Triassic rocks preserved, which are the Chinle Formation. And then underneath this little sandstone that's down here, we have, right down in here, we can see some of the Moenkopi, which is another Triassic unit. So we'll take a look at some of this Chinle stuff that we have here, and take a look at this formation. It's just a beautiful morning, and it's exciting to be out here taking a look at some of this geology. Fantastic geology. Now the Chinle Formation is one of Utah's red formations, red beds, these red rocks that make Utah fairly famous for all these red, brightly colored red rocks. And we have this wonderful exposure of the Chinle Formation. So at the top we see coming across the nugget Navajo sandstone, which is supposedly, it depends on who you ask, but Jurassic, early Jurassic is sort of what the consensus right now, though it might shift into the Triassic. Not many fossils come out of it, and there's some new material coming out of it that may indicate that it's slightly older. And then we have the late Triassic Chinle Formation. And out here we can see that there is a sandstone that kind of comes off, that's kind of a whitish sandstone in the middle of this cliff behind me. And that sandstone is the Gardea Member of the Chinle. Below that you see another red formation, and this red formation is called the Moenkopi. And the Moenkopi is a very interesting unit. If we were to look at it, it's tidal flat, so it's basically these very nicely laminated horizons. There's some outcrops right behind me. And then there's an unconformity between the Gardea Member of the Chinle, which is that kind of whitish layer, purplish layer that's coming across. In southern Utah, that's the Chinook Member of the Chinle. And then above that we have sort of the, here it's not really named, but it'd probably be equivalent to the Petrified Forest Member of the Chinle. And that's the horizon we're going to take a look at today. You can see there's some interesting units right above there with some interesting yellow patterns and patterning. And that's because a lot of these deposits of the Chinle are sort of ancient soils. So these are terrestrial deposits, so rivers, ponds, sometimes you can get some lake type deposits in the Chinle. And then you get a lot of paleosoils, which are going to create these interesting banding patterns between red and whitish colors. And that's because of the way that the soils form in terms of drawing down certain minerals, especially the carbonates that are going to create the white layers. And then in the upper horizons of those soils are going to be more red, and they're going to be red because of iron oxide. Now the Chinle is a really interesting formation because it preserves an interesting period of time for North American geology. And that is a time in which there was a major shift in the plate tectonics of the continent. So during the Paleozoic period, the North American continent was being pushed eastward, and it had basically ran into the other continents that formed the Appalachian Mountains. But around the late Triassic, around the time of the deposition of the Chinle, the continent started to shift and move westward for the first time. And it's been continually moving westward since then for over 200 million years. And that meant that a major rift valley formed on the eastern seaboard of today's North American continent. And it started to move westward, and what ended up happening as soon as it started to do that is that it started to run over the Pacific plates, whereas before it was sort of fleeing those Pacific plates, it was being pushed away. So when this happened, it was like it getting tousled between two areas, to the east and to the west, and so it started to shift towards the west. Eventually this is going to lead to mountain ranges that are going to form like the Wasatch and the sphaerorogeny, but this is the very beginning of that stage. And so the Chinle, the deposition of these rocks in this basin, represent a terrestrial basin that was forming at the very onset, the very initial onset of today's modern plate tectonics, which is shifting the North American continent to the west. So right now I'm in the basal sandstone of the Chinle Formation. This is the Gardea, used to be called the Gardea Member of the Chinle. They dropped the grit, so now it's just the Gardea. But it's really different, and I want to show you how different it is from the overlying Nugget or Navajo sandstone. And if we take a look at it, break some pieces off of it, we see that it is actually a conglomerate. And it's filled with fairly coarse-grained bits and pieces of silica, of quartz grains. They're not really well-rounded, which is really interesting. So this conglomeratic unit, we have like little pebbles in here that, given that they're not well-rounded, they are probably, there's even a little bit of feldspar in it, which is really interesting. Looks like mostly quartz, but it's not super mature. So a lot of these bits and pieces of grains were transported by ancient rivers. These grains are too big to be transported by wind, like we saw in those Jurassic units up above. So in the Triassic, this conglomerate was being deposited. And what's really interesting about this is that they've looked at the zircons that are in this to get some provenance. And they found that it's just chock full of zircons that are about 1.7 billion years old, as well as a bunch of them that are Cambrian, so about 580 million year old zircons. That indicates that this rock is composed of other bits and pieces of ancient rocks that were deposited in towards the southeast into Colorado, coming out from this basin that was forming with the Uncompadre uplift, which probably means that the ancestral Rockies were still a little bit of a high topography that existed even into the Triassic. So kind of interesting to see this. This conglomerate is also interesting because, as I mentioned before, the tectonics was changing at this time during the late Triassic. And so the North American continent was starting to head west. And so the fact that we're starting to see conglomerates indicates, especially conglomerates with pretty big class in it, indicate that there was some topography that was existing at this time. If we go into the Paleozoic, it's a passive margin. We don't see conglomerates in the Paleozoic out here. It's, tidal, marine rocks, carbonates, things like that. But conglomerates like this usually indicate that there's proximity to some sort of topography, whether that's some hills or mountain ranges. We're having, a pretty strong river here transporting fairly large class that you don't see on a beach, that you don't see in sand dunes that are wind transported. So this is a really interesting unit, and it's sitting right on top of the Moenkopi. Interesting soil concretion. I'm working on a paper describing some of these unusual soil concretions that you find in the Chinle. And the Chinle is really interesting. We have evidence here that it was that these rocks were deposited, these layers were deposited at a time in Utah's history which was very different than today. At that time, the Chinle was being deposited in a Utah that was next to an ocean, a vast ocean, and Utah was wedged up against Pangea. So to the east we had the rest of the continents, and then to the west we had oceans. And so we were near the equator, but the other thing that's really interesting is we have a lot of evidence with these unusual soil concretions, as well as these crystals that I'm finding everywhere. Crystals of gypsum, which is a white mineral, and you find beds of gypsum. Now gypsum is a evaporitic mineral, and probably what was happening was that you're dealing with a sort of super monsoonal system, maybe on a decade sort of scale, where you'd have a decade, 10 years of just tons of rain that would fall out. This is similar to what we find in the El Nino La Nina cycle of modern day climate. But this is on a super scale because the entire ocean was on one side of the world and all the continents were on the other side. So the oceans were the temperature in the oceans was probably sloshing back and forth a bit like the modern Pacific Ocean. And this would result in sort of a super El Nino La Nina cycle. Really intense wet periods and then really intense dry periods. And during the dry periods, the gypsum would form. And the gypsum would basically be formed as all this water evaporated away. So all the ponds, the lakes, everything would evaporate away and leave behind the gypsum. During the wet periods, we'd have soil formation. So that water would percolate and saturate the soil. If it did that enough, that cycle, all these cycles happening, it would leave behind these really weird concretions of calcium carbonate in the soils. And you see that in the Chinle. So it represented a very different world than we have here today. Here's what I was looking for. You can't go very far in the Chinle without finding petrified wood. Petrified wood is very common in the Chinle. A lot of times it's silicified. That means it's been replaced. The wood itself has been replaced by silica. And this means that it doesn't weather as readily as the mudstone and siltstone that surrounds the petrified wood. So here's a nice example of some Chinle petrified wood right here. One of the other interesting facts about the Chinle Formation is that it's a rich deposit of uranium. And in the 1950s, a lot of uranium mines sprung up to mine uranium ore, which is basically what this stuff is here. This actually has a lot of hematite in it, but you can see this yellow stuff that's in here. This is what the old uranium miners called yellow cake. And this is basically uranium ore that would be mined. It tended to, when you have a high concentration of uranium, it tended to be this yellowish color. And a lot of times they were found in some of these conglomeratic units in the lower part of the Chinle that were mined for uranium. Most of the uranium mines, even today, are around Moab, down near Monticello. Up here in the northern part of northeastern Utah, there's no active uranium mines. But this is what they'd be looking for, these types of deposits here. And I'm actually standing next to probably an old uranium prospecting road that went through here. You know, we might not be finding very many fossils today. The Chinle is not necessarily very fossiliferous, especially in Utah. But boy, the view is amazing. You can see the Weber sandstone in the background, sitting right here with the wonderful nugget. And just below me is just this wonderful stretch of Chinle Formation, this late Jurassic red rocks that are so characteristic of Utah. Now I feel like I'm not doing justice to the Chinle Formation. I should travel around the southwest, especially in the Four Corners, if we wanted to get a really good picture of the Chinle. But the Chinle can be found all the way far into eastern Colorado, down near the Purgatory River. But it's just a wonderful and interesting unit, and I wish that it was more fossiliferous than it is. I bet if we spent a day or two down here, you might find something. You might find some of these phytosaurs, although I'm unaware of any fossil localities in this region. But it is nice just to come out here, look around at these rocks, and to realize how just impressive the scenery is here in Utah. I so much want to climb up on top of this cliff, but I broke my my radius last weekend. So I was mountain biking and I did a header, and unfortunately that makes me unable to climb this, but I think it would be some fantastic views on top of the sandstone ledge. But I don't know, the view from here is just incredible. And it's just nice to get out and even with a broken arm, take a look, try to do some geology and look at some of the spectacular rocks that we have here in Utah.